We present Pearl, a physical environment-based mixed reality approach for exploring human movement data in situ. In daily life, the physical environment shapes our movement and behavior. For example, in an exhibition room, presented items might affect how the visitors behave and navigate the environment. While exploring movement data in situ, analysts can be interested in how people engage with the environment and objects. Considering physical objects as reference can be the key to extracting and presenting these insights. We propose exploring movement data in situ by referring to surrounding physical objects as regions of interest. We design novel interaction and visualization concepts for exploring movement data considering spatial and temporal relations to the environment. To support a coherent analysis workflow, Pearl consists of 3 components: selector, filter, and visualizer. With Pearl Selector, we enable the creation of lenses, which defines spatial volume and represents the region of interest within the physical environment. A lens is embodied as a cuboid bounding box, displayed as either a full wireframe or only with implicit corner indications. A lens can also be removed, selected, and grouped through freehand gestures. To refine the scope of a lens, a drag or body gesture can be performed. The latter modifies the lens by the distance between the analyst and the physical object, allowing for situating recorded humans' perspectives. Through Pearl Filter, we allow reducing data complexity and refining selections based on regions of interest, in order to cope with the infamous spaghetti heaps issue of 3D trajectories. To this end, positive or negative filters will show or hide trajectories, either on the actor level or here on the data point level. A dynamic process of filtering is supported, and analysts can immediately see the outcome of the filtering intervention. Furthermore, multiple lenses can be combined with basic logic operators to form one global filter query on the actor level. For instance, regarding interactive installations, we can learn that there are only 2 people who have either interacted with the monitor or the foot pedal, using 2 positive filters in a logical OR relation. In addition, by using AND logical relations, we can learn that only 1 person visited both of these artistic 3D sculptures. As you can see, the hand movement represents as a base trajectory can be traced easily. Lastly, Pearl Visualizer is for displaying detailed and accurate visualizations for selected movement data. We represent 4 visualization classes in relation to the region of interest, which considers data characteristics and the applicability of the combination of detailed and aggregated visualizations. For instance, we propose showing aggregated magnitude data directly superimposed on the physical objects, like the superimposed 3D stacked bars showing the visit frequency of 2 visitor groups. Next, we design various floor-embedded aggregated visualizations for spatial and relation data. For instance, Flow View with 2 color-coded visitor groups shows the trend of location transition in terms of direction and quantity. Similar, Sequence View summarizes the location transition of individuals regarding 2 color-coded visitor groups. Next, Pace View aggregates average movement speed with fixed width linkages in a heatmap-like fashion. Approach View aggregates the number of people approaching the physical object by placing radial bars around the region of interest. Lastly, the 2D heatmap shows the overview of the aggregate time of humans based on locations. In Pearl Visualizer, we also design situated 2D information visualizations placed next to the referent for complex analysis, as well as 3D spatial temporal visualizations in the space, such as 3D trajectories, for situational details. Such layout coordination of visualizations allows for the combination of aggregate and detailed visualizations, for instance, co-located view. It consists of a situated 2D gunshot with a local timeline overview, helping identify the appearance of people at the same time, and 3D trail visualizations with animated avatars for additional details. On the basis of expert review sessions in a simulated exhibition room, we are convinced that our approach of referring to physical objects as region of interest has great potential for movement data analysis. For more details, please refer to our paper.